The global energy market relied on a single, untouchable mathematical assumption that China's demand for imported crude oil would simply grow forever. In a massive shock to global markets, official data confirms that China's transportation oil demand has permanently peaked and entered a terminal decline, completely altering the geopolitical balance of the 21st century. Sodium, the sixth most abundant element on Earth, now sits at the heart of China's battery cost revolution. The calculus is simple, but devastating for the old order. While lithium carbonate prices have whipsawed between $40,000 and $80,000 per ton, industrial sodium chloride, essentially refined ocean salt, trades at less than $100 per ton, with global supply chains measured in the hundreds of millions of tons per year. This raw material advantage is not theoretical. CATL's Naxtra line, announced for volume production in 2026 at the Ningde plant, is engineered around sodium feedstocks and hard carbon anodes, eliminating the need for graphite and high-purity lithium. BYD's parallel sodium-ion project in Shenzhen follows the same playbook, integrating sodium salt production modules into existing electrode infrastructure. The manufacturing flow is direct. Sodium chloride is refined to high-purity sodium salts, then processed into NaPF6 electrolyte and sodium manganese oxide cathode powders. Hard carbon anodes, derived from biomass or petroleum coke, are coated onto copper foil without the complex lithium intercalation steps required for conventional cells. The result is a line speed of 30 meters per minute, slower than graphite, but offset by a tenfold reduction in material cost volatility, and a capital expenditure profile of $150 million per 5 gigawatt-hour line, according to KTL's published figures. Early pilot runs report cell-to-cell variance under 2%, and first-pass yield rates already above 85%, with optimization targets set for 92% within 6 months of ramp-up. On the economics, the numbers are explicit. NION cell costs are projected at $70 per kilowatt-hour for CATL and $72 for BYD, undercutting LFP lithium-ion by 10% and high nickel, NMC, by more than 25%. A 50 kilowatt-hour electric vehicle pack built with sodium-ion cells lands at $5,800, $600 below the LFP equivalent. For mass market vehicles, this translates to a retail price drop of $500 to $700 per car, pushing the entry-level electric vehicle below the $10,000 threshold for the first time. The impact reverberates through the supply chain. China's 2024 to 2025 procurement guidelines now earmark 20% of new energy vehicle battery orders for non-lithium chemistries, with state subsidies rewarding sodium adoption. For the global oil market, the strategic implication is clear. By collapsing the battery cost floor through abundant domestically sourced sodium, China has engineered a tipping point. The old math of oil for mobility no longer holds. The sodium-ion supply chain, from salt to finished pack, is not just a technical milestone. It is the industrial lever driving the terminal decline of Chinese oil demand. Composite polymer ceramic electrolytes have rewritten the limits of battery performance in China's solid-state revolution. Laboratory benchmarks published by the Shanghai Advanced Materials Institute and the University of Science and Technology of China report ionic conductivities between 1 and 5 millisiemens per centimeter, on par with the best liquid electrolytes, but with none of the volatility or fire risk. Gravimetric energy densities on pilot scale stacks now reach 320 to 350 watt-hours per kilogram, verified through 4 probe impedance spectroscopy and IEC 626603 protocols. These metrics are not confined to academic abstracts. In March 2026, a joint consortium led by SAMI and CATL began pilot line validation at scale, achieving 88% first pass yield of cells exceeding the 300 watt-hours per kilogram threshold, a leap over the below 50% yields that dogged early solid-state attempts. The immediate impact is the annihilation of range anxiety for premium and long-haul electric vehicles. During a 2025 on-road demonstration, a 95 kilowatt-hour solid-state pack delivered 1,050 miles on a single charge, with zero cooling system activation, an unprecedented figure in commercial electric vehicles. TÜV Nord certification followed in June 2026, confirming zero thermal runaway events in 10,000 charge and discharge cycles. The elimination of lithium dendrite-induced short circuits and the absence of flammable solvents mean that catastrophic battery fires, once the Achilles heel of high-energy systems, have been functionally engineered out of the equation. This was not a lone laboratory achievement. The University Industry Consortium structure, backed by direct state procurement and a network of advanced materials suppliers, compressed the cycle from bench to pilot line in under 3 years. Roll-to-roll manufacturing under inert atmosphere, in-situ hot pressing for composite membrane densification, and real-time impedance monitoring have transformed solid state from a technical curiosity into an industrial asset. The strategic implication is explicit. With greater than 1,000-mile range, zero fire risk, and mass-manufactured reliability, the last technical refuge for oil-powered premium and long-haul transport has collapsed. The performance pillar is now in place. The adoption flip is no longer a speculative scenario. It is enforced by the hard metrics of Chinese supply chains and the relentless logic of industrial policy. China's light vehicle market crossed a threshold in 2024 that rewrote the logic of global energy economics. According to the China Association of Automobile Manufacturers, 52% of new passenger vehicles registered that year were electric or plug-in hybrid, 6.9 million units out of 13.3 million total. For the first time in any major economy, internal combustion engines became the minority technology. The inflection was not driven by environmental mandates, but by a collapse in battery costs and a relentless push for industrial scale. CATL and BYD, leveraging sodium-ion and LFP chemistries, delivered electric vehicles below $10,000, undercutting gasoline cars across every segment of the mass market. Municipal planners in Shenzhen turned this national trend into a complete urban transformation. By the end of 2025, official audits confirmed that every one of the city's 21,000 public buses and 98% of its 45,000 taxis had gone fully electric. The impact on oil demand was quantifiable. Daily diesel consumption for public transport dropped from 30,000 barrels to just 4,800 barrels, an 84% reduction. Over a year, this eliminated nearly 9 million barrels of transport fuel, slashing the city's exposure to imported crude. The Municipal Transport Authority's own figures show that electrification of the bus and taxi fleets alone accounts for a 2.5% drop in total urban oil demand, a figure that would have been inconceivable even 5 years earlier. This was not a showcase for foreign investors or a pilot for export. The Shenzhen case is the operational blueprint for what happens when battery supply chains, vehicle original equipment manufacturers, and local government procurement operate in lockstep. Sodium-ion production lines, running on salt-derived feedstocks, fed directly into the city's bus and taxi assembly plants. Subsidy structures rewarded non-lithium chemistries, while municipal contracts guaranteed volume for domestic suppliers. The result was a structural, not cyclical, break in urban fleet dynamics. It is a template now under review by transportation ministries from Chengdu to Jakarta. As electrified fleets scale and oil demand contracts, the logic of the old petroleum order is being dismantled in real time, one city audit at a time. China's rail engineers are executing an infrastructure substitution on a scale without precedent. The national plan, codified in the 14th Five-Year Transport Outlook, sets a target of 60,000 kilometers of high-speed rail by 2030, up from 45,800 kilometers in operation at the end of 2025. Construction is proceeding at a rate of approximately 4,500 kilometers per year, with new lines connecting secondary cities and major logistics hubs. This is not a symbolic project for urban elites. It is a deliberate strategy to erase oil-intensive travel modes from the national energy ledger. The modal shift is quantifiable. Internal Ministry of Railways analytics confirm that each kilometer of high-speed rail diverts an average of 120,000 annual passenger trips from short-haul aviation and long-distance diesel bus routes. By 2024, the high-speed rail network was already displacing an estimated 5% of domestic short-haul flights, primarily those under 800 kilometers, according to SYNPRY and Bloomberg-compiled ticketing data. The impact on jet fuel demand is direct. Oxford Energy Institute modeling attributes a reduction of 5 million barrels per year in aviation fuel consumption to high-speed rail expansion alone. On the freight side, electrified rail corridors now absorb 12% of intercity ton kilometers previously handled by diesel trucks, amplifying the contraction of road fuel demand. Railway planners, working in tandem with the National Development and Reform Commission, have mapped a scenario where the 60,000 kilometer network will carry over 1.3 billion passenger kilometers annually by the end of the decade. This scale of electrified movement is engineered to cut not just gasoline, but also diesel and jet fuel from the transport energy mix. The refinery product slate is already shifting in response. As passenger and freight volumes migrate to electric rail, the proportion of gasoline and diesel in total crude throughput is falling, making room for higher value petrochemical outputs. The rail build-out is not an isolated megaproject. It is the backbone of a systemic transition away from oil as a transportation fuel, quantified in millions of barrels and enforced by the relentless metrics of passenger and freight flows. Refinery control rooms across China now monitor a different set of metrics than they did even 5 years ago. The traditional dominance of gasoline and diesel in the crude oil slate has been broken. By the end of 2025, official throughput data from the National Energy Administration show that transport fuels, gasoline and diesel account for just 48% of total refined output, down from over 60% in the previous decade. The remainder is increasingly routed to petrochemical feedstocks, naphtha, ethylene, propylene, and specialty polymers. This is not a marginal adjustment. State-owned giants like Sinopec and PetroChina have retooled major complexes to maximize chemical yields, investing in advanced catalytic crackers, hydrocracking for light olefins, and direct crude to chemicals units. Internal refinery planners now optimize for propylene and polyethylene output, not for maximizing fuel barrels. The underlying driver is structural. As electrified vehicles, buses, and high-speed rail erase millions of barrels of annual transport fuel demand, the economic logic of refining has flipped. The transport segment, once the engine of oil demand, is now a shrinking share. Feedstock ratios have shifted so far that according to Sinopec's 2025 annual report, petrochemicals now absorb 45% of crude input, up from 31% in 2018. Gasoline output fell 8% year-on-year in 2025, while propylene and specialty chemical volumes grew by double digits. For the first time, China's oil import strategy is not about keeping the cars running. It is about feeding the plastics, fibers, and advanced materials sectors. This operational pivot strips oil of its former weaponizable leverage. With transport fuel demand in terminal decline and chemical feedstock use set by industrial planning, The old geopolitical calculus, where oil shocks could cripple mobility and economic stability, no longer applies. The refinery slate has become a barometer of energy independence, not vulnerability. The strategic anxiety now shifts outward as oil exporters face a future where China's demand for transport fuels is no longer the anchor of their fiscal security. Emergency meetings inside Gulf energy ministries have become routine. Saudi Arabia's Ministry of Energy convened its Diversification Acceleration Program in August 2025, citing the abrupt contraction in Chinese gasoline imports as an immediate catalyst. Internal memos from Riyadh detail a revised 5-year production outlook, slashing planned upstream investment by $18 billion and reallocating capital toward non-oil sectors, renewables, and tourism. The UAE's energy planners responded in parallel, fast-tracking the Masdar-led Green Hydrogen Export Roadmap and launching the $20 billion Energy Transition Fund in early 2026. OPEC Plus summit briefings reference emergency scenario planning for a future where China's transport fuel demand is no longer a reliable anchor. Market analytics from Bloomberg and Wood Mackenzie warn of a potential annual revenue shortfall of $150 billion for the Gulf if Chinese oil lifelines continue to contract at present rates. Sovereign wealth funds are now under pressure to increase allocations to technology and infrastructure assets in Africa and Asia, explicitly referencing the risk of stranded oil assets. The policy language has shifted from managing cyclical price swings to confronting structural demand loss. In less than 2 years, the world's core oil exporters have been forced into a strategic pivot, with diversification no longer a long-term aspiration, but an enforced response to China's industrial realignment. Chinese trade officials now operate a dedicated export coordination office, tasked with scaling the post-oil ecosystem abroad. The model is direct. Ultra-cheap electric vehicles, powered by sodium-ion or LFP battery packs, are bundled with turnkey solar microgrid kits and shipped to emerging markets on concessional terms. In 2025 alone, over 2 million Chinese electric vehicles entered Southeast Asia, Africa, and Latin America, with prices under $10,000 and bundled infrastructure loans underwritten by state policy banks. These packages include not only vehicles, but full charging and solar deployment, delivered as a single financeable unit. Export contracts signed with Nigeria, Indonesia, and Brazil specify 5-year payment windows and local assembly provisions, locking in market share before Western automakers can respond. The financing structure mirrors the Belt and Road playbook, with below-market interest rates, sovereign guarantees, and technology transfer clauses that bind recipient states to Chinese supply chains. Internal documents from the Ministry of Commerce detail a target of 5 million electric vehicles exported annually by 2028, supported by a revolving line of credit from the China Development Bank. The result is a global demand shock. Oil importers in the Global South now face a ready-made alternative to gasoline dependency, while Western automakers are squeezed out by China's scale and cost advantage. The post-oil kit is not a concept. It is a containerized, shipped, and financed reality, engineered to suppress worldwide transport fuel demand before rival supply chains can mobilize. A skeptical analyst identifies 5 technical and infrastructural risks shaping China's battery transition. Sodium-ion batteries, once doubted for cold weather reliability, now show over 90% capacity at minus 40 degrees Celsius. CATL's Naxtra cells have covered 500 kilometers in deep freeze trials, though a plus or minus 3% uncertainty remains across repeated cycles, leaving extreme climate performance an open question. Solid-state manufacturing, long challenged by defect rates, has improved. Pilot lines in Shanghai raised first-pass yields from under 50% to 88% in 2 years, thanks to advances in polymer ceramic densification and real-time monitoring. Electrolyte costs have dropped 40% since 2022, but high-purity ceramic supply is still limited, with only 3 domestic suppliers meeting new standards at scale. Raw material bottlenecks persist. Sodium chloride is common, yet conversion to battery-grade NaPF6 and manganese oxide cathodes relies on a few specialized refineries. Eve Energy's 2 gigawatt-hour plant targets 96% material utilization, but volatility in nickel and vanadium supplies continues to inject risk. Grid and charging infrastructure is expanding rapidly. 180 gigawatts of new renewables and 65 gigawatts of fast charging capacity are expected by the third quarter of 2025, and sodium-ion battery swap stations now number over 850. Still, grid studies predict up to 5% curtailment risk, with provincial load balancing unresolved. Recycling remains early stage. Sodium-ion batteries emit 12% less greenhouse gas than lithium-ion, and hydrometallurgical recovery rates reach 85%, but recovery uncertainty stays at plus or minus 4%. Scenario modeling from China's top battery industry scientists now quantifies the oil displacement range under 3 adoption speeds. In the fast penetration scenario, where sodium-ion and solid-state chemistries reach 40% of all new electric vehicle packs. By 2028, and high-speed rail expansion stays on its current 4,500 kilometers per year track. Transport sector oil demand contracts by an additional 300,000 barrels per day by 2030 compared to the baseline. This outcome is driven by a compounding effect. Battery cost parity triggers a 70% electric vehicle share in new sales, while urban diesel and jet fuel demand are further compressed by full electrification of bus, taxi, and regional rail fleets. The base case, reflecting current procurement quotas and infrastructure build rates, projects a 180,000 barrels per day decline by 2030, with electric vehicle market share stabilizing near 60% and high-speed rail offsetting 7% of domestic aviation fuel. In the slow adoption pathway, where sodium-ion supply chain ramp-up stalls and solid-state yields plateau, the contraction falls to just 90,000 barrels per day, with new energy vehicles capped at 50% of sales and only incremental gains in rail modal shift. Analysts highlight 3 signals: year-on-year, electric vehicle registration growth above 15%, sodium-ion pack prices consistently below $70 per kilowatt hour, and annual high-speed rail additions exceeding 5,000 kilometers. If these thresholds are met, the upper bound scenario becomes the default. The sensitivity is clear. Each incremental 10% in electric vehicle penetration accelerates oil demand decline by 50,000 barrels per day, compressing the forecast window for global supply chain adaptation. The global oil calculus now pivots on factory output, not tanker routes. As China's sodium-ion and solid-state battery supply chains scale, energy security is achieved by logistics, minerals, and grid connectivity, not by barrels. Gulf oil producers confront a terminal demand shock. Western automakers scramble for relevance. The industrial center of gravity shifts permanently. The energy race is no longer who controls oil, but who controls the battery. Your move, world.